Hello everyone, in this video we are going to be applying the trigonometric ratios to finding a missing side on a right triangle. In a previous video we considered the three trigonometric ratios, the sine, the cosine and the tangent. And we figured out that the sine of an angle is the ratio of the opposites to the hypotenuse, the cosine is the ratio of the adjacents to the hypotenuse, and the tangent of any angle is the ratio of the opposites to the adjacent. And of course, all of this relates to a right triangle. And we know what a right triangle is. It's a triangle that has one of its angles to be 90 degrees. If you want to see the previous video, just click on the link at the top right hand corner of your screen. Now, we're going to be solving three problems here. Okay, here are the questions. In each problem, obtain the value of x. So I've got three problems here. Starting with the first one, we can see that this triangle is a right triangle because one of its angles is 90 degrees. We are given another angle, 27 degrees, and clearly this side labeled x is its opposites. So we have O, and of course, this side here is the longest side, and it's the side facing the right angle sine. So that makes it the hypotenuse. So we've got an additional h. So looking at this, we can see that the sine is going to be most appropriate. Thus, the sine of 27 degrees is going to be the ratio of its opposites, that's x, and the hypotenuse, that's 25. So in order to obtain the value of x here, we are going to have to cross multiply. Of course, we know that this is sine 27 over 1. Cross multiplication is going to produce x equals 25 sine 27 degrees. So this is 25 times sine 27 degrees is 0.4540. The product of this is going to give 11.3498, and we can just approximate correct to one decimal place, and this is going to be approximately 11.3 centimeters. This is the value of x. Okay, the second one, clearly this side is the hypotenuse because it's the side facing the right angle sine. Now we've got an angle here, 50.2 degrees. That makes this side its opposite, and of course the other side with x as its adjacent. So we are asked to obtain the adjacent and we're given the hypotenuse. Looking across all three functions here, we are going to see that the cosine is going to be most useful. Thus, the cosine of the angle 50.2 degrees is going to be equal to adjacent, that's x, over hypotenuse, that's 13. We are going to cross multiply as usual, and this is going to fetch us x equals 13 cos 50.2. This is 13 times cos 50.2 is 0.6401. Multiplying that by 13 gives 8.3214. And if we approximate correct to one decimal place, that gives 8.3 centimeters. Now the final one. So this is also a right triangle. We can see that this side is the hypotenuse because it's the side facing the right angle sine. This side right here is the opposite of angle 60, and that leaves the third side as its adjacent. So we've got the opposites. We are asked to obtain the value of the adjacent. Looking across all three, we can see that the tan is going to be useful. Thus, the tan of the given angle, 60 degrees, is going to be equal to opposites, that's 4, over adjacent, that's x. We are also going to cross multiply here. So this is going to give x times tan 60 being equal to 4 times 1, and that's just 4. Dividing both sides by tan 60 would give x equals 4 over tan 60. And we know what tan 60 is. Tan 60 is 1.7321. So 4 divided by 1.7321 is 2.3094. And if we approximate this correct to one decimal place, this is 2.3 centimeters. So this is how to obtain the missing side of a right triangle using the three trigonometric functions. If you find this video useful, kindly like, share, drop a comment, and do not forget to subscribe. Thank you for watching. See you in the next video.